Hello everyone, my name is Ivan Ramirez. I work at the CFAA at the library, and today I'm going to show you an example of the L'Hopital's rule. Okay, we're going to solve this limit, the limit when x goes to x, when x approaches to 0 on the right. And as you can see, the behavior of this limit is of the form 0 or to the power of 0. And you know that the L'Hopital's rule can be applied if you have a limit of the form infinity over infinity or 0 over 0. So we can't apply the L'Hopital's rule yet. We have to do some algebraic manipulations, and after that we can apply the L'Hopital's rule. So first of all, I'm going to call the function x to the x, I'm going to call it y. And then I'm going to apply it ln in both sides of the equation. So that would be this. After this, I'm going to apply the exponential function again. So this is going to be y equals e to the x ln of x. So notice that we had y equals x to the x, but now we can rewrite the function x to the x as e to the x ln of x. And actually this is better because after this we can apply the L'Hopital's rule if we do some algebraic manipulations again. So what we have is the limit when x goes to 0 on the right, but instead of write x to the x, I'm going to write e to the x ln of x. Now by continuity of the exponential function, this becomes to be e to the limit when x goes to 0 on the right of the function x ln of x. Now let's focus just on this limit. I'm going to write it again, limit when x goes to 0 on the right of the function x ln of x. And notice that this limit is of the form 0 times infinity, because the behavior of the function ln when x approaches to 0 on the right is infinity. So we cannot apply the L'Hopital's rule yet. We need to do something else. So I'm going to write this again, the limit of the function when x goes to 0 on the right of the function x ln of x. And notice that we can rewrite this as the function ln of x over 1 over x. It's actually the same. I haven't changed anything. But the thing now is the behavior of this function is going to be infinity, because the ln when x approaches to 0 goes to infinity, over 1 over x, and the function 1 over x when x approaches to 0 on the right is going to be infinity too. So now we can apply the L'Hopital's rule. So by the L'Hopital's rule, we can say that this is the limit when x approaches to 0 on the right of the derivative of the function that is on top. And you know the derivative of ln is going to be 1 over x, and the derivative of 1 over x is going to be negative 1 over x squared. After this, we just have to calculate this, which is negative x squared over x. And this is the limit when x goes to 0 on the right of negative x. And we just have to plug in x equals 0, which is 0. Sometimes people make the mistake and they think that this is actually the answer, but remember what we had was the limit on top of the exponential function. So now the answer is going to be e to the limit of x ln of x, and we already know that that limit is going to be 0. So our answer to this problem is going to be e to the 0, which is 1. This is the answer of the limit we were working at, and I think this is a very important exercise because it's a little bit different. It's not of the form infinity over infinity or 0 over 0. And it shows you that sometimes you have to do some algebraic manipulations in order to apply the L'Hopital's rule. So I hope you have learned something today, and thank you for watching this.